preparation of haloalkanes, there are number of methods of preparation. Let us look into them one by one. First one is from alkanes. Preparation of haloalkanes from alkanes. It is a direct halogenation of hydrocarbons. Alkanes means all the carbon atoms in the molecule are linking by only single bonds. No presence of double bond and triple bond. It is direct, what is that? Substitution. What is meant by substitution? Replacing one atom by the other atom. You are replacing hydrogen atom by chlorine or halogen. It is called substitution reaction. And this reaction involves free radical mechanism. Let us see what is the free radical mechanism. I am taking the simplest alkane CH4. By the action of chlorine in presence of light, we get this chloro derivative of methane, CH3Cl and HCl is a byproduct. What is the reactivity? First is the action of light on the chlorine molecule. One photon of light acts on the chemical bond. That is, chemical bond breaks symmetrically. Here the bond breaks symmetrically. What is symmetrical breaking? The atoms will take back the shared electron for the bond formation and get dissociated, resulting in what is that called free radicals, the atomic state here. The free radicals thus obtained are reactive, the reactive species, which can act on the reactant molecule methane. That is the structure of methane. The action of chlorine free radical on this chemical bond. There are four similar chemical bonds, CH, CS, CF. It can act on any one of them. The action is resulting in the breaking of chemical bond is again a symmetric breaking. This H is removed, the Cl is added. What is that? Cl replaces H, resulting in the formation of another free radical, H, reactive species. Because of reactivity, it will act on the other reactant molecule because there are a number of reactant molecules. This results again symmetric breaking of this bond, the action of this. Here, due to this action, this free radical. Now, due to free radical action on this, again you get what is that? HCl and chlorine free radical. When this free radical is forming, this will proceed with the reaction same as this step, because this step is by this chlorine free radical. This chlorine free radical has come from this step. Now it is coming from this step. So it is repeating with the other methane molecule producing H, and this follow this reaction. It will react with other chlorine molecule producing Cl. These two steps are repeated once it is initiated. That is initiation. So this is required for the initiation. Light is required for the initiation. It is initiated, and further what is that? The steps what is not is producing. They what is that followed by themselves, repeating themselves. It is called propagation reaction. These steps are repeated till all this almost all methane and chlorine molecules taken are completely reacted to give this compound on acid. This is monoderivative. This is monoderivative. Now the reaction will not stop over here. There are 4 hydrogen atoms. After this hydrogen is attacked, now this hydrogen can be attacked by the chlorine in the same fashion, resulting in the formation of CH2Cl2. And again, this hydrogen, after this hydrogen can also acted by this chlorine molecule, generated now by this forming this molecule. Finally, in this compound, after this chemical formation, this compound formation, this bond is also acted upon by the chlorine radical in the same fashion, forming CCl. Look here, it is not only mono, it is di, tri, tetra. It is chloromethane, dichloromethane, trichloromethane, also called as chloroform. Tetrachloromethane is also called carbon tetrachloride. We get a mixture of these four compounds by the action of chlorine and methane. But the relative amounts, that is the percentage of each component in the mixture, are different. The percentage depends on the relative amount of the two reactants what you take in the reaction mixture. If you take more amount of methane compared to chlorine, these two becomes a major product, these two becomes a minor product. More amount you get, less amount you get. But if you take more amount of, relatively more amount of chlorine than methane, this becomes these two becomes a major product, these two becomes a minor product. It depends on the percentage of each, relative amounts of these components depends on the relative amounts of the two reactants we take in the initiation. This is the product, mixture of product you get. This reaction is not prepared for lab preparation, but this reaction is prepared for industrial production. It means large scale production, manufacture. So this is how we can get mono derivative of alkane. Let us move on to the higher hydrocarbons like this. This one and this one. That is propane. That is, what is that? 4 carbon atoms in chain. That is a linear chain and it is side chain, methane. That is propane, 3 carbon atoms. Let us, what is the action of halogen atom? That is chlorine on this, chlorine on this. Look at this. So let me talk about only mono substituent, because this is predominates. Mono means this chlorine can act on the hydrogen of this carbon, and this chlorine can also act on the hydrogen of this carbon atom. In some molecules, the chlorine act on this. In some other molecules, chlorine act on this hydrogen, resulting in the formation of this one. Action of chlorine on this carbon result this product. That is, HCl is removed. HCl byproduct is not shown here. And when the chlorine acting on this produces this first carbon. That is Cl, one H plus, one H is replaced, one H is replaced. This H is replaced, another H is replaced. Get mixture of two compounds in this case. In this case also, what is higher alkane, that is side chain. We see this chlorine can act on this hydrogen, the chlorine can act on this hydrogen, one of the hydrogen atoms, not this hydrogen atom. Result in the formation of this one. The reaction of chlorine on this hydrogen forming this, H is replaced by Cl. The same thing remains. And in other molecules, the chlorine acting on this hydrogen removes and Cl is added here, substitution. HCl is not shown by product. We get these two compounds. Mixture of these two compounds, in this case, mixture of these two compounds. That is action of chlorine. Let us see what is the action of bromine on this. Same. That is first carbon, second carbon, bromine. Look at the difference. First here a major product, minor product. The reason for this, here very important, in organic chemistry the concept selectivity. What is selectivity? Selectivity for substitution is what is that is greater 3 degree, 3 degree greater than 2 degree greater than 1 degree. Stability. This carbon is more stable with the substitution than this carbon and this carbon. That is why the what is that reaction prepare this carbon than this. Now look at why it is major, why it is minor. In case of this is 2, this is 1. But carbon with the 2 carbon is called this secondary carbon, this is primary carbon. Therefore, major predominates over this. Selection. It is selection. Prepare selection on the basis of this. And the chlorine is look at, in addition to this, what is that selectivity, it is also depending on the reactivity of the other reactant. Other reactant is this, Br and this. Reactivity is in this order. Fluorine reactivity is greater than Cl2, it is greater than this, greater than this. That is among Cl2 and Br2. Take a note. Cl2 is more reactive than Br2. Because Cl2 is more reactive than Br2. So now look at this here. Now you look at this point. We expect this as a major product, but it becomes a minor product. Reason here, your chlorine is reactive. When the reactant is more reactive, they will deviate from the expected reaction. When the because chlorine is more reactive, because what is that? While looking for hydrogen to attack here, these hydrogen atoms, so it is nearby, no crowd, 6 hydrogen atoms here come in the path. Therefore, chlorine is reactive, it can attack this hydrogen instead of this hydrogen. That is why this reaction is prepared. That is reactivity, is prepared over the selectivity. Reactivity is predominates over the selectivity. That is selection, that is due to reactivity. This happens. But the same reaction with bromine, it entirely reverse. This becomes a minor, this becomes a major. This is actual. That is because of this stability. What is the reason? Bromine is less reactive. Bromine is less reactive. Where the other reactant is moderate reactive or less reactive. If that is the case, then we see the reaction has expected. Expected is expected in accordance with what is that hydrocarbon. That is stability, according to this stability. Selectivity. Therefore, this reaction prefers selectivity, selecting this for this substitution. So remember that the selectivity and reactivity in organic chemistry plays an important role in most of the reactions. Decides what is the actual end point. Here actual end point is this. Actual end point is this. Look at the difference. Only reactants are there. So selectivity and reactivity. Selectivity depends on the carbon type of carbon. Reactivity depends on reactivity of the other agent. So this is most important in organic reaction. We see most of the reaction. This will define which is the actual end point, major product and minor product. So that is about what is the preparation of the halogen derivative chlorine and bromine, like this, higher hydrocarbons. And finally we look for preparation of iodo derivative. This reaction is similar to this reaction, no difference. Cl2 iodine you take. If you take iodine, same reaction, no action of light produces this and this. But this reaction is reversible. Will not proceed, go back. What is the reason? Look at the product nature. HI, here HCl. Among this, that is strong oxidizing agent, it is less sorry, strong reducing agent, it is less reducing agent. Both are reducing agent. This is stronger, this is weaker. 1 point. Reducing means one which donate hydrogen freely. It is this hydrogen. And another point, look at this. The bond between this carbon and iodine, the bond between chlorine and that is carbon and chlorine. This bond is stronger, this bond is weaker. So this can act, give hydrogen, take back iodine. So they can't give back. What is that? Because of weak chemical bond and strong reducing agent, it reverses easily, but this will not reverse. It will proceed like this. That is, with this reaction, we don't get a yield, because as the reaction progresses, it will again come back. So idea to what is increase the yield, you have to remove this as and when it forms in the, as and when it produces. So idea is strong reducing agent use a strong oxidizing agent. These two are strong oxidizing agent. HNO3 and HiO3, hydroiodic acid. So you know that reducing agent and oxidizing agent readily react. Mixing in the reacting system either this or this. Mixing this with this or this now, with this reactant, what you get, as this Hi is produced, this will act on this, readily produce iodine and water. So it is removed as I2 and H2. These two will not react on this. Unreactive to this will proceed. So if this is there, the reaction proceeds, but this is removed as this and this. We get more amount of, this is the idea to increase the yield of the reaction by the direct hybridization of methane. So this is how we can get derivatives. What is that? More derivatives from the alkenes. Halogen derivative from the alkenes. Second method from alkenes. Alkenes means there must be double bond between the carbon and carbon. By the action, what is that? Reagent for the preparation, this it is either that is halogen molecule or halogen element on the compound like this, halogen derivative, halogen compound like this, HCl, HBr, Hi, or Cl2, Br2, I2 like this. This is soluble in CCl4 solution, no, highly soluble. We can use this. It is solution of CCl4 bromine and mixed with this. It readily, what is that? This bromine molecule will be added to the double bond. Here, one bond is sigma bond, other bond is pi bond. Pi bond is weak. It can be acted upon easily by any reagent. So this addition, what is that? Acting is simply added. Bromine molecule is added to this, breaking of this chemical bond, forming a chemical bond like this. What is vicinal dihalide, vicinal compound. If HCl is added, that is H2 Cl2 other, either this or this. In this case, what is that? It is what is that? Unsymmetric, that is symmetric. Here, if we go for higher alkenes, that is next higher alkene. This alkene is symmetric. Reason, between the carbon and carbon is connected to hydrogen, 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 hydrogen. Similar, symmetric. But in this higher, what is that? Propene, CH3, CH2. Around the carbon, double bond. This carbon is with one hydrogen, CH3. But this carbon with hydrogen is different. It is called unsymmetric alkene. Unsymmetry about the double bond. If that is the case, what is the addition? The major product is this. Not this. You get 2 chloropropane, not 1 chloropropane, because Cl, if as per this, no, Cl can act like this. But if the Cl bonded to this, becomes dichloro. If Cl bonded to this, 1 chloropropane. But this is a major product. It is in a accordance with the concept of Marconi capsule. Let me go in brief, not in details. Already was basically dealt with. That is, what is that mechanism involved is electrophilic addition. First, a dissociation of HCl, that is into H plus and Cl, by unsymmetric break of the chemical bond. The chemical bond between H and Cl unsymmetrically broken as H plus and Cl minus, both the bonding electron transferred onto chlorine, that is Cl minus H plus. Nucleophile, electrophile, that is unsymmetric bonding liberates positive charge and that is release positive charge and negative charge. It is electrophile, it is known as nucleophile in organic chemistry. This electron deficient can attack, that is electron pi bond electron rich can attack this pi bond by bonding this carbon or this carbon. If bonding with this carbon, this result carbocation C plus, this bond breaks, bonding with this plus pass on to this carbon. If this hydrogen bonding with this, we get this result plus here CH2. Here plus 2. Look at this compound. This is 2 degree, this is 1 degree. Secondary, primary. As you know, now selectivity. This selectivity means this is more stable than this. So hydrogen attack and bonding with this. This results what is that? 2 carbon. It is more stable than the with this 1 degree. Attack this is more stable. This is more stable than the other one. Therefore, this prefers selectivity. This is reaction prefers this. After this, what is the steps? Second step, the nucleophile minus will attack this because minus attack the plus neutralizes boring chemical bond. Cl. This is a compound we expect. This is major compound. This is minor compound. Not possible. This is possible. This is the mechanism of what is that Marconi capsule. Next, let us move on to the little higher alkene like this. In place of CS3, what is that? We have CS3, CS3, CS2. That is either. As per the addition of Marconi capsules, we have now hydrogen. That is the hydrogen to this we get CS3. Cl to this we get this compound. We should we expect this compound. We expect this compound, but not possible. This compound is not found, but this compound is found. Look at that. Chlorine is here. Should be supposed to be, but chlorine is to this. You get this compound. What is the reason? Let us look into the mechanism. That is the mechanism. First step is as it is. Action of H plus, addition of H plus to this CH3, that is carbocation. After the formation of carbocation, look at this surrounding. That is the next adjacent environment to this carbon is this is the environment. CH3 H plus. That is H now is there in this carbon atom. Now this is second carbon, this is tertiary carbon. Is there any rearrangement like this? Or what is that? After the formation of this carbocation, is it further stabilizes by any rearrangement? Any further stabilization possible? By rearrangement it is possible because in the next adjacent, very much adjacent to this hydrogen, this hydrogen, this chemical bond breaks away, breaks into take away, but both the electrons are taken away. It is called H minus, not H plus. Hydride anion, that is called H minus is hydride ion, both the electrons taken by this. What is next now? Without electron, H plus hydrogen ion. Give both electron to other, becomes H plus hydrogen ion. Difference is H minus hydride ion, H plus hydrogen ion. This is broken, and what is that? Removed as this, and bonding with this carbon. This becomes neutralizes. CH, that is CH becomes CH. Now plus is just pass on to this. That is delocalization of plus into this and shifting of this hydrogen. as I write like this. Look at the difference. Why? Because in adjacent immediate vicinity, it is the possibility. That is the possibility. We see that we get this same molecule with this configuration. This configuration. What is that? This is carbocation 3 degree. Carbocation, which is more stable. According to selectivity, this is more stable. Due to selectivity, what is that? There is a rearrangement. So if there is any possibility of what is that kind of rearrangement to produce further more stable compound, this is more important usually in compound. There is one more step is involved. Already multi steps, complex reactions are multi steps. That is one more step is is involved, just a further stabilization. So among this is more stable. For further stabilization, if there is any provision like this undergo kind of rearrangement. That is called selectivity. Now after this, what is that? Chlorine will attack this. That is why we get this compound, not this compound. Preferably in this case, if you have this molecule like this. That is what is that? Mechanism of electrophile attack. That is what you get. And last one, it is the same molecule. What is that? Mercury molecule. Here addition of HCl, HBr. In place of HCl, here in place of HCl, if you use HBr as well, you get the same compound. That is Br is here. Marconic oxide. But the same reaction, not with HCl, HBr. If we have this compound in the mixture, that is peroxide, organic peroxide, benzyl peroxide. Benzyl means benzene CO, the peroxide in presence of light. So this, what is that? Reverses, exactly reverse of Marconic oxide. This Br will bond it to this, H will be bonding this. Exactly reverse. Addition is exactly reverse of Marconic. It is called anti-Marconic oxide crash effect. Now you get this compound, not the compound like this. What is the reason mechanism? That is, it is electrophilic attack, that is free radical mechanism. Because of this compound, undergo what is that? Chemical, what is that? Breaking up, symmetric breaking with the action of light produces free radical. This free radical will attack this reactant, producing this compound and free radical like this Br. Now the Br can act on the double bond. Here initially H plus acting, but Br free radical is acting. Next step, first step. After this step, no, Br is acting. With this Br acting and forming chemical bond with this carbon, get this now. We get what is the free radical at this carbon, second carbon. Free radical at the second carbon, that is 2 degree. Suppose Br act on this forming chemical bond with this, we get free radical at this carbon, CH2, that is primary 1 degree. So 1 degree, 2 degree, no, that is more stable selectivity. So this is stabilized. So compound is more amount of this compound is forming, and after this, what is that? This free radical, this is free radical. This act on other HBr, resulting in the formation of what is that? H bonding with this, and this has Br free radical. So this will propagate further. The same, what is that? Thus, as what is that? Br thus releasing will what is that? Will carry the reaction step like this in the same manner to get all the reactant molecules reacted to give product like this. That is propagates just like the law. So once it's initiated, that is released.